Hello everyone, welcome to my YouTube channel. My name is Evidence, and in today's video I am going to show you how to create a 3D future dependence plot. Okay, in the last two videos I showed you how to create a single future dependence plot, and in this video I also explain what future dependence plot is. So if you need that information, if you need to know how to create a single future dependence plot, and if you want to learn what future dependence plot is, go ahead and watch this video. And then the last video I released, I showed you how to create a two future dependence plot. And in today's video, I'm going to show you how to create a 3D future dependence plot. So this is still a two future dependence plot, but this is going to be in a 3D format. So this is going to be fun. So first, let's go ahead and import everything that we need to import. Why not? What you need to import to make this happen is you need to do pip install PDP box, and then from PDP box.pdp import basically everything: PDP interact, PDP interact plot, PDP isolate, PDP plot. So just go ahead and import everything. And then you also need to do from sklearn.ensemble import random forest regressor, and then import seaborn as SNS, import plotly.graph object as go, pip install category encoders, and this is what I use for encoding my data frame. And then import category encoders as CE. So I've already installed PDP box, so I don't need to install this again. I'm gonna comment it out. Now I already installed category encoders, so I don't need to install this again. So no, I said as go. You know, I need to stop making typos. Okay, so make sure you install these two things first. And if you don't have Seaborn in your local environment, make sure you install Seaborn. If you don't have Scikit-learn, make sure you install Scikit-learn. If you don't have Plotly, make sure you install Plotly. You know, so make sure you install these things before you try to import them. But I am in Google Colab, so I know I already have all of these things in my environment. But once you have installed everything that you need to install and imported everything, then you can start coding. So let's start by just creating a model using a pipeline. Oh yeah, if you want to use a pipeline like me, you need one more thing from sklearn.make.pipeline. Import make pipeline. If you want to use a pipeline like I am about to use, make sure you install pipeline first. In a different video, I go into detail of how to create a pipeline and how to work with the pipeline. But in this video, I'm just going to use it without going into deep explanation. If you want to learn more about pipeline, make sure you check out that video. So I'm just going to call it forest. It's equal to make pipeline. And then I want ce.onehot encoder. So this is basically me encoding the data frame, and then random forest regressor. And I want all the default parameters. And also quickly, so I already have my X-train data. Before I got to this point, of course, I already cleaned my data and got it ready. And as you can see right here in the status column, The status column is categorical. We have developing, we have developed. It's categorical. We need to turn this categorical column into integers. That's why we are doing the encoding process. So now that we have instantiated our pipeline, let's go ahead and fit our model. So forest.fit, and we want to fit our X train and then our Y train. All right, and as you can see here, using our pipeline, first the encoding process was applied, then the random forest model was applied. Like I said, go watch the video on pipeline. So now that we have imported stuff that we need, we have instantiated our model. We have fit our model. Let's go ahead and actually create a function for doing a 3D plot. So let's do def PDP. Let's call it 3D. All right, what do we need here? We need to define feature 1, feature 2. We need our test data. We need what our estimator is gonna be, and we need our target, and then we need our title. So the features we're gonna be using, let's call it features 2, just for clarification. So when you go back and look at this notebook later, you won't be confused like feature, like which one is which. So I'm gonna call it feature 1, feature 2. So I'm making a list of the features we are going to be using. So let's call it interaction is equal to PDP interact. And the model is going to be the estimator. The data set is going to be the test data. The model features is going to be the test data dot columns, and then the features is going to be features 2. All right, so if you look at this very helpful documentation that Google Colab shows us here, we need to provide a model, and the model is the model that we already trained. The data set here is the test data that we are going to be applying this PDP interaction to. The model features is the column names, and then the features is like the columns that we're interested in, that we want to be working with. So now that we've defined our interaction, so let me just call it PDP is equal to interaction. That's this interaction right here. Dot PDP dot pivot table, and then values is equal to pred. Columns is equal to features and position 0, actually features 2. And then the index is equal to features 1. Okay, so basically what this is showing us right here is like we are taking the data from this and putting it in a table format. All right, and then we are creating a pivot table from this, and we are saying that the values for the pivot table is like the predictions from this model right here. It's going to use this model to run prediction on the test data, and then we are saying that the columns is what's going to be on the column side of the features of the table is going to be feature 1, and we are saying that what's going to be on the index side of this pivot table is going to be feature 2. So let's just call it surface is equal to go.surface. All right, and then x is equal to pdp.columns. Y is equal to pdp.index, and then our z is equal to PDP dot values. So basically we are defining the surface area for our graph, and we are defining, like we're saying, that x is the columns, the y is the index, and then the z is the values from here, columns from here, index from here. So now that we've defined the graph area for the 3D plot, let's go ahead and define the layout of the 3D graph. So go dot layout. Whoa, it has like so much stuff, like ugh. Okay, so let's do scene is equal to a dictionary. S-axis is equal to dictionary. Y-axis is equal to dictionary. Title is equal to features 2, position 1, and then Z-axis is equal to target. And then the title is equal to title. Alright, so basically, so we are defining the layout of the 3D graph here. So we are saying that layers equal to go.layouts, like go, graph object from plotly go.layout, and then we define the scene. So our scene is gonna be a dictionary from this, and then we have x-axis. So our figure is going to be go.figure, and we want the surface and the layout. The data here is located in surface, and then we have the layout, which is this right here. And of course, the surface is created from PDP interaction. So this is what's going on here. We use random forest to fit our model. Then we define our interaction, our PDP plot interaction. Then we got a pivot table from this interaction that we defined right here. And then we created our surface from that information we extracted. And then we created our layout. And now we are plotting the surface and the layout. Alright. And we want to make sure we do fig.show. Let's go ahead and run this, and if we have any errors, we'll come back and fix it. So now let's go ahead and actually use our 3D feature interaction plot. So PDP 3D, and I want HIV/AIDS, and I want schooling. And then my test data is going to be my S test. And then the estimator is going to be forest. That's what we call the model. So my target is life expectancy. Okay. And then title is equal to. So we have defined all of this. Let's go ahead and run this. Key air alcohol. All right, so I found the typo. Okay, this was the first typo I had here. I just had features instead of features 2. Okay, I just had features, and this was a second typo. So if I go ahead and put it back the way it was, and then run this, go back here and run this again. See, we get that error right here. Okay, but if we go back here and change this to features 2, so if you're typing along, make sure features 2, like features 0 is the first feature, features 1 is this. All right, so if we go ahead and fix that, run this and run this again, we get another error that says module object is not callable, and that's this right here. So this needs to be capital letter S, not small letter s. If we go ahead and fix it and run this, and run this again. Now it works. So yeah, just simple typos like that will like mess up everything you just did. So basically this is a 3D graph of life expectancy, HIV/AIDS, and number of years spent in school. So this is pretty cool. I like it a lot. 3D graphs are cool to look at. It's more like eye candy. Like it does provide value, but like it's very difficult to kind of like interpret a 3D graph standalone like this. But the coloring for these 3D graphs kind of looks like what we had here. So if we go back up here and look at the two future dependence plot that I created, and this video is from last week, you can see what we have here. You can see that with less death from HIV/AIDS and increasing number of schooling kind of like is correlated with higher life expectancy, and more death per 1,000 and less years of schooling is kind of correlated with lower life expectancy, right? We have yellow eye here and then purple color. And then if we look at our eye candy graph, it kind of reflect that a little bit. I mean, without using the 2D graph that I already created last week, it's kind of difficult to interpret this just looking at it, but we can kind of see a similar pattern here where like life expectancy of 75 is kind of higher and it's kind of more yellowish with less HIV/AIDS death and more years of schooling. So just looking at a 3D graph is kind of difficult to kind of like interpret it. It's mostly for eye candy, just to catch people's attention, right? And it looks pretty cool. But if you want interpretable graph, you most likely use a 2D graph. And you can go watch the video from that I uploaded last time that shows you how to create a 2D dependence plot. Now I wanted to show you one that is like super cool. So we can do one between HIV/AIDS and BMI, and let's see what it looks like. So a BMI has spacing between it. That's what it is. So it's kind of looks like a flash sheet. Again, it looks super cool. If you're working on your data science project, you can kind of use 3D graph as eye candy material. But the coolest one of them all that I've ever created is between schooling and BMI. And that just looks dope. Talk about eye candy. Like, bro, that looks so dope. It's like, if you want like super eye candy stuff for your data science project, this would be it. And also, you can see like the contours, like the edges here. That looks absolutely dope. It looks like a step. You can see kind of lower life expectancy down here, higher life expectancy. So you can see more years in school and a lower BMI. It's kind of like higher life expectancy. Like I said, it's very difficult to get a reasonable interpretation from a 3D graph. It's mostly for visuals. That's basically it for this video. That is how you create a 3D graph representing a 2D PDP box plot. Last week I created this, which is a 2D PDP plot, but using a heat map. But this week is kind of same information, but in a 3D format. I hope you enjoyed this video. To get access to this tutorial notebook, just go to machinelearningeducation.com. So this is a platform I created for giving you access to all my notebook and all my resources in one place. So once you are here, if you click on this link, it will take you to this page, machinelearningeducation.com/free. And this is where I have all my free data science resources, like the name says. And this notebook and any notebook that I use in my tutorial YouTube videos is going to be found here. And I also put my blog posts here and my YouTube videos here. And you can find me online at evidencen.com. This is my primary website where I write data science blog, and as time goes by, I'm going to add more stuff to this data science blog. And if you are here on evidencen.com, you can also click on free data science resources and get to this page so you can get access to this notebook. That's it for this video. Thank you for watching, and I'll talk to you on the next one. Bye.